A geometric sequence has first term a, common ratio r, and sum to infinity 76. A second geometric sequence has first term a, common ratio r cubed, and sum to infinity 36. Find r. We know that sum to infinity is equal to u1 over 1 minus common ratio, provided that the absolute value of a common ratio is less than 1. Hence, this 76 is a over 1 minus r, and 36 is a over 1 minus r cubed. We get simultaneous equations, and we can see that if we divide both sides, a cancels, so let's divide both sides to get 1 minus r cubed over 1 minus r is 76 over 36. I want to multiply each term in numerator and in denominator by -1 to get r cubed minus 1 over r minus 1 is equal to, we can divide by 4 to get 19 over 9, and you can see that we get an equation of degree of 3, and it's paper 1 question, so without a calculator. And how can we solve it? Let's consider r cubed minus 1. 1 is a root, hence r minus 1 is a factor, and using remainder theorem it can be rewritten as r minus 1 multiplied by polynomial of degree of 2, and let it be p r squared plus q r plus s, and since 1 is a root, r minus 1 is a factor, so remainder is equal to 0. And how to find PQS? You may expand the right hand side and then equating coefficients in front of same powers of r, you can find r, q, and s. Or we can divide r cubed minus 1 by r minus 1. Divide polynomials. I will use synthetic division, you may use long division. How it works: 1 here, -1 here, write 1 here, and coefficients of this polynomial, since it's of degree of 3, there must be 4 coefficients, and coefficients are in front of r cubed, it's 1, in front of r squared 0, in front of r 0, and -1. Then we rewrite this, and then this multiplied by this, and right here 1, then add up 0 plus 1, and right here 1, then 1 times 1, right here 1, sum is 1, and then 1 times 1, 1, and we get 0. There must be 0. Why? Because it's a remainder, and if 1 is a root, or 1 minus 1 is a factor, remainder must be 0. And it's P, it's Q, and it's S. So it becomes r minus 1, r squared plus r plus 1. Hence, this becomes r squared plus r plus 1 is 19 over 9. Multiplying by 9, we get 9r squared plus 9r plus 9 minus 19, so minus 10 is 0. Using discriminant, it becomes discriminant b squared minus 4ac. Can factor out 9, so it becomes 9 plus 40. Hence, square root of this discriminant is what? 3 times 7, it's 29. Hence, roots are minus b plus root of this, so 29 over 2a, so over 18, and it's what? 12 over 18, which is 2/3. And another root is -9 minus 21 over 18 is -30 over 18. But since the absolute value of common ratio must be less than 1, and it means that it's greater than +1 or less than -1, and you can see that it's less than -1, so it's impossible. Why? Because the sum to infinity to exist at all, the absolute value of a common ratio must be less than 1. So there is only one solution, it's 2/3. And that's all for this question.